Hello everyone. In this session, we are going to discuss about the difference between TCP and UDP. TCP and UDP plays a very vital role and a very important role when it comes to transporting the data from one system to another or one system to multiple systems in the network. So every single activity happens or starts from IP. So IP is the foundation. IP is the underlying protocol for the network. So either it is internet or intranet. So all the data routing, the responsibilities at the network layer, the IP, either IP version 4 or IP version 6. So IP is where it all begins. IP is responsible for basic networking. With that said, TCP and UDP, it plays a major role when it comes to the actual data transport, the actual data transmission. So at transport layer, this is the ISO OSI model, right? These are the 7 layers we have got, starting with your physical layer where you have the network interface card and you have the Ethernet and point-to-point protocol working at the data link layer, and you have the TCP and UDP at the transport layer. So TCP stands for Transmission Control Protocol. It is a very reliable protocol that guarantees the delivery of data from one source to another destination. Okay, it is used for applications which are very business critical, which are looking for guaranteed delivery. Like if you are doing a file transfer from one system to another system, so your intention is to transfer and succeed there. If you are doing some web browsing, you want to get the output there. So web browsing, file transfer, all these are good examples of TCP. UDP is in contrary, it is a kind of comparatively unreliable protocol compared to TCP because it does not guarantee the delivery of data. So see, it in general, these kind of application does not need guaranteed delivery. For example, when I'm speaking over the internet through live streaming, or if someone is doing a video conferencing, see, you, if for example, if you are on a Skype call or in a Teams call, if your side network fails or if you have some network issues, see, I'm not responsible for that. See, as a person, if I'm attending some seminar or webinar, I have to have a reliable internet. If I'm doing playing something, I mean, it's, don't take it serious. So if you are playing games online, um, see, we need to have a reliable network and high speed quality network so that I can play the games in a much efficient and faster way. So that these are good examples, right? Streaming media, video conferencing, online games. So these are all working based on user datagram protocol. So it uses real time steaming protocol. Whereas if you look at the TCP, so sending emails or sending files or securely connecting to the system or browsing web pages, all these are good examples of TCP. So let's get into the actual comparison now. So TCP, as I said, there are many different protocol. TCP has the port number 06. Okay, 06 is the port number for TCP at a very high level, but for each and every protocol part of TCP, it will have its own port number. For example, file transfer protocol, this is the protocol through which you are transferring files, documents, and data between devices. Okay, so it uses port number 20 and 21 for data transfer and connection, whereas there are many other secure protocol like TFTP, SFTP, and so on. So that will use different port number. For example, TFTP stands for Trivial File Transfer Protocol, where it works on port number 69, and SFTP, Secure File Transfer Protocol. So it works on port number 22, where encryption is the key, Secure File Transfer Protocol, right? And you can also use Telnet, which works on port number 23. So there are many different protocols which are part of TCP connection oriented protocol. It has got different port number, but at a high level for TCP, 06 is the port number. And similarly for UDP also, you have for this connectionless protocol, you have port number 17 for UDP, user datagram protocol. So this is the port number for UDP. So TCP is called as connection oriented protocol. So for example, if you are trying to connect from one device to another device, from your client machine to server, or system to system, so what will happen with TCP is that the TCP protocol will do a three-way handshake. It will go and try to send a synchronization packet, and once it gets the acknowledgement and confirmation, then only it will go and do the data transmission. So without that, the TCP protocol will not start delivering the data. So it requires a established connection before it can send the data. So TCP needs a established three-way handshake, and it validates the connection before it transmits the data. So it is not happening in the UDP. UDP will just do the data transfer irrespective of the connection. There is no handshake, there is no connection validation. So it will just send the see, if you are doing a live streaming, so I mean, if you are talking to someone over the Skype, see, we cannot guarantee the other person or other end network connection or stuff. So they have to have a reliable bandwidth. If they have a reliable bandwidth, UDP will work very seamlessly. Okay, so you can have continuous calls for 2 hours, 3 hours, or whatever duration you want. So the header size in TCP is little higher. So 20 bytes to 80 bytes, it differs on different protocols to different application requirements. So here in UDP, it is very standard size, 8 bytes. It is 64 bits in total. So 1 byte is equal to 8 bits, right? So you have 64 bit size, which is very smaller. So the transmission can also be much faster. So acknowledgement is definitely needed before TCP can send the data, but here acknowledgement is not needed. So you can directly start sending the data, and whatever data you are sending, it goes in a sequential way. So there is no guarantee here for sequential data transfer, but it will also work sequentially if the files are getting, or if the data transactions are happening in an organized way. But it mostly works in a random way here. So it's all data packets here. Here it's all called datagram. So if there is a interruption, or if there is any issues, if the packets are failing to arrive on the destination, so it will also try data retransmission. So here there is no retransmission. If you are talking to someone over the video call, or if you are trying to play games, if someone is already giving a speech, or if the other players are playing the online games, see, you cannot pass and continue. So whatever he has talked, it will I mean, if it is recorded, then yeah, you will be lucky enough to go and go through the recording, or else whatever he has spoken, or whatever the online other players are covering, you will not be able to get it back. So lost data can't be retrieved in UDP. So delivery is very guaranteed in TCP. Here there is no guarantee, and broadcasting is not supported here. TCP does not support that. TCP is point to point mostly. It is like unicast in majority of the case. See, for example, you are sending a packet, you are sending an email, you are trying to access some web page. So it's all client to server unicast connection. Whereas here in UDP, it supports unicast, multicast, and also it supports broadcast as well. TCP is comparatively heavyweight because of the sizing of the header size, and even the data. So comparatively, UDP is lightweight. And here in TCP, you get error checking. Okay, so it checks whether the data is getting delivered, whether the data is getting arrived. So if there is any error, it will validate that error checking, and it will also recover the issues that we have got. So here also in UDP, there is a very minimal error checking, but it's not that good as TCP. The speed is comparatively faster, okay, in UDP, but if you look at TCP, it is comparatively slow because it has to do a three-way handshake, it has to do error checking, it has to confirm whether the connection is proper, and all those acknowledgement has to be received before it sends the data. So that is the reason there is a slowness here, but it completes the data delivery. There is a guaranteed data delivery. So if you are talking about applications which need guarantee, and if you need a kind of what do you call, if reliability is the key, then obviously you have to go for TCP. So in TCP, you get better reliability. In UDP, you get comparatively better speed. It's not that too fast kind of thing. So TCP and UDP at the network level, there will be a minor difference, but UDP is definitely faster than TCP because it uses real-time streaming protocol kind of stuff. So you get a better speed and comparatively it is very very speed. So there is also option for flow control in TCP. You don't have that flow control option in UDP, and you also have security options in TCP. Even UDP also supports protocols like IPsec and so on. So it's not that UDP is completely unreliable and unsecure. Not like that. Okay, so there also you get secure options to encapsulate send the packets in a tunnel and have better security. But TCP also supports security options in all the different protocols. Like file transfer, it supports TATP, SFTP, and then when you want to connect to system, it supports SSH. And if you want to have web browsing done, you can also, it also supports SHTTP or HTTPS. So TCP is kind of slightly heavier compared to UDP because it requires 3 data packets to even before send the transmission. It before, just to connect it, it has to have 3 packets to start with. Okay, so a very good example of TCP is the file transfer, email, web browsing. So all these are good examples here. So it is comparatively slower, and UDP is comparatively faster, and you only get best effort delivery of your packet, like your voice over IP and music streaming, online gaming. There are many different examples. So here you can see you can have a one-on-one call, or you can also have a one-to-many live streaming, or you can also have a broadcast done in UDP. Okay, so you can have a multiplayer game, or you can have a one-on-one conversation. You can also do a live online streaming of your whatever I'm doing now, right? So it's a kind of broadcast. It's going to get broadcasted in YouTube, so where many people might have watched it. But the recording was done by just me, and I'm sharing it. So this is how it works. So TCP has to do a 3-way handshake before it can do a data transmission. But here it is sending data, and it all depends on the receiver side whether they are ready to receive and accept it. So these are the top 7 or 8 use cases that we have for the UDP. The remaining all majority of them are TCP related use cases. So live video streaming, it requires very low sensitivity, very low latency. So there is um, it is a real-time application, right? It uses real-time streaming protocol. So it uses UDP for connection. See, DNS is a kind of little exception, I would say. Why it is? See, here most of the queries are handled via UDP. So then that is a catch, right? They are saying most of the queries. Then in certain cases, DNS also uses TCP. What kind of cases? For example, if I have a DNS zone and I want to transfer some of the zone data to another DNS server, so those kind of things happen through TCP, the zone transfer in DNS and certain management and those activities. It uses TCP in DNS. So TCP DNS uses TCP and UDP. So if you ask me, like, are there any other protocol that uses TCP and UDP both? Yeah, you should be aware of it, because see, whenever you are working on a firewall request, or whenever you are working on a change request where you have to specify the port protocol and all those things, so you need to specify whether it uses TCP or UDP, because the network engineer has to, or the firewall engineer has to appropriately select the protocol used at the transport layer. See, for example, if you want to allow RDP, remote desktop protocol, it uses both TCP and UDP, the 3389 port number, right? And then if you're using DNS as an example, whatever we are discussing now, it also uses TCP and UDP. And similarly, LDAP, if you know about Active Directory, it has a lightweight directory access protocol. So all the data related to that particular activities, LDAP activities, it uses the 389. 3389 is RDP, sorry about that. But LDAP 389 port also uses both TCP and UDP. So there are some protocols which uses both TCP and UDP. And if you're asking me what are the examples of UDP, I thought I have shared it. Let me check. Okay, so that is not mentioned here, right? For example, NTP uses network time protocol, through which you are receiving your time, and then the beautiful SNMP tool, which you are using for managing your network, routers, switches, devices, all the stuff. Simple network message protocol, the SNMP, NTP, the real-time streaming protocol, RTSP, session initiation protocol, SIP, DHCP. DHCP also uses UDP, port number 67 and 68. So those are all something which you need to be aware of. So here also market data multicasting uses UDP, and then whatever messages or live notification that you are receiving right from the Internet of Things or IoT devices, it also uses UDP. Whatever online gaming we are playing with multiplayers or online gamings are using UDP. Whatever IPsec tunnels we are creating to secure our traffic or connection between two different sites, it also uses UDP. And finally, time-sensitive transmissions, where you need fast data transmission like DNS lookup or online gaming or video streaming. All these uses UDP. So these are all good examples of UDP. Thank you for listening.